Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for finding minimum element in a rotated sorted array. Let's look at the problem description. We are given an array of n elements which are in sorted order, and that array may be rotated 1 to n times. Given that sorted array nums of unique elements, we have to find the minimum element in that array. Okay. And then we have to write an algorithm that runs in order of log n time complexity. Let's take a look at the example one. So here the array has 5 elements and that array is rotated 3 times. Okay. In this, the minimum number is 1. So that is an output. And in the case of example 2, the array has 7 elements. In this, 0 is the minimum element. So output is 0. In the case of example 3, the array is not rotated, or we can say it is rotated 4 times. In this case, the minimum element is number 11, so the output is 11. The constraints for this problem are the n is the number of elements in the array, and n is ranging from 1 to 5000, and the value of individual element is ranging from -5000 to 5000. And all the integers of num are unique, and the nums array is in sorted order, and it may be rotated 1 to n times. Let's look at the approach to solve this problem. We are given a nums array which has 5 elements. In this, the smallest number is 1. That's the output. Brute force approach is to scan through this array linearly and keep track of the smallest element we have seen so far. At the end of scanning this array, we have the smallest number. The time complexity of this approach is order of n, because we have to process all the numbers. Only then we can find the smallest number, right? But we are expected to solve this problem with order of log n time complexity. We can use binary search technique to solve this problem with order of log n time complexity. Okay. Basically, we maintain 2 pointers, start and end, which points first and the last element of an array. And also we have a variable which keeps track of the smallest number we have seen so far. Okay. So each iteration we compute the mid index value, and then we compare the smallest number seen so far with the element pointed by the mid pointer. If the middle element is smaller than the smallest number seen so far, then we update the smallest variable. Once we updated it, we have to decide which part of the subarray we have to choose to search further, right? For example, in this case, we have the element 5, that is the smallest seen so far. Next, we have to decide whether we have to continue the search on this side or this side. Okay, because the array is rotated, we cannot just simply use the middle element's value to decide which side we want to proceed. Okay, so what we need to do is we have to compare the current start number and the end number. Whichever is smaller, then we compare that small number with the smallest number seen so far. Okay, so in this case 5 is the smallest number seen so far. We compare 3 and 2. 2 is smaller. So next we compare 2 with 5, because there is a chance that this side probably have the smaller number. We compare the end element's value with the smallest number, because this is smaller than the mid element. We have to set the start pointer to point to mid plus 1. Otherwise, we update end pointer to point to this element. Similarly, if this number is smaller than this number, then we have to compare this number with the smallest number seen so far, and then update the start and end pointer depending on the result. Okay, we repeat this until the start and end pointer cross each other. Finally, the smallest variable will contain the smallest number in the array. So that's what I have written here. First we initialize the start, end, mid pointers and then the smallest variables. Then traverse the nums array until the start and end indexes cross each other. Each iteration we compute the mid index, and if the value at the mid index is less than the smallest, then we update the smallest variable with the middle element's value. And then we compare the value at the start index and the value at the end index. If the start element is less than the end element, then we compare the start number with the smallest variable. If the start number is smaller than the smallest, then we update the end index with mid minus 1. Otherwise, we update the start index with mid plus 1. If the end element's value is less than the smallest, then we update the start index with mid plus 1. Otherwise, we update the end pointer with mid minus 1. We repeat this until the start and end indexes cross each other. Then finally, the smallest variable contain the smallest number in the input array. Let's look at the flowchart. Input for this find min procedure is the nums array. First we initialize the variable start, end, mid and smallest. Start is initialized with the index of the first element of the input array, and end is initialized with the index of the last element in the input array. The mid is initialized with 0, and the smallest variable is initialized with 5001 because as per the problem description, the valid range for the individual elements in the array is minus 5000 to 5000. So to begin with, I initialize the smallest variable with the 1 plus the largest valid number. So that's why I set it with 5001. Next, we compare whether the start index is less than or equal to the end index. If that is true, then we compute the mid index value, and then we compare the middle element with the smallest number seen so far. If the middle element's value is less than the smallest, then we update the smallest variable. Next, we compare the numbers pointed by the start and end indexes, and if the start number is less than the end number, then we compare the start number with the smallest value seen so far. If the start number is smaller than the smallest, then we update the end pointer with mid minus 1. Otherwise, we update the start pointer with mid plus 1. Okay. So if the number pointed by the end index is less than the number pointed by the start index, then we compare the end number with the smallest variable. So if the end number is smaller than smallest, then we update the start pointer with mid plus 1. Otherwise, we update the end pointer with mid minus 1. We repeat this process until the start and end pointer cross each other. After coming out of the loop, finally we return the value in the smallest variable as the output. Let's move on to coding. First I initialize the start index with value 0 and the end index with the value length of the array minus 1 to point to the last element of the array. And then I initialize the mid index with value 0. And then I initialize the smallest variable with value 5001, which is 1 plus the largest value of any individual elements in the array. Okay. Next I write the for loop. This will run until the start and end pointer cross each other. Each iteration I compute the mid index value. Next I compare the mid element's value with the smallest variable. So if the mid element's value is less than the smallest variable, then I update the smallest variable with the mid element's value. Next I compare the elements pointed by the start and end index. If the start element is smaller than the end element, then I compare the start element's value with the smallest number seen so far, which is present in the smallest variable. If the start number is less than smallest, then I update the end pointer with mid minus 1. Otherwise, I update the start pointer with mid plus 1. If the end element is smaller than the start element, then I compare the end element's value with the smallest variable. If the end element is smaller than the smallest, then I update the start pointer with mid plus 1. Otherwise, I update the end pointer with mid minus 1. And finally, I return the smallest variable's value as the output. Next, I'm going to run the test cases. Oops, there is a compilation error. There is a typo. Let me rerun the test case. All the tests passed. Next, I'm going to submit this program. Cool, this program is accepted. Next, I'm going to do the code walkthrough with sample input. We are given the nums array with 5 elements, and 1 is the smallest number in this array, so that's why the output is 1. Okay. So first we initialize start and end indexes to point to the first and the last element of the input array. So in this case 0 and 4, and mid index is initialized with 0, and then the smallest variable is initialized with value 5001. Okay. Next we enter this for loop. So when we enter the for loop, the start index is 0 and the end index is 4. Okay, and the mid index is 0 plus 4 minus 0 divided by 2, 2. So it points to this element. Okay. Next we compare the mid element with the smallest variable. So the mid element's value is 5. The smallest seen so far is 5001. Because this is less than 5001, so we update the smallest variable with 5. And then we compare the number pointed by the start and end indexes. So here start is 3 and end is 2, and end number is less than the start number, so this else part is executed. Here we compare the end number with the smallest variable. So we compare 2 with 5. So this is less than 5. So we update the start pointer with mid plus 1. So basically we choose this part of the subarray for further search. So now the start will be 3. Okay. So that's why start is 3, end remains 4, and mid index is 2, and the smallest seen so far is 5. And in the next iteration, again we compute the mid index. In this case the mid index is 3, and we compare the value pointed by this mid index with the smallest variable. So the mid element is 1. So 1 is less than 5, so we update the smallest variable with 1. Okay. Next we compare the element pointed by the start and end pointer. So in this case 1 and 2. So 1 is smaller than 2. So this if part is executed this time. So again we compare the start number with the smallest number seen so far. So in this case start is 1 and the smallest seen so far is also 1. Because both are equal, then we go ahead and update the start pointer with mid plus 1. So in this case the start pointer will become 4. Okay, and then in the next iteration we compute the mid index. In this case the mid index value is 4, and we compare this with the smallest variable, but the smallest variable contains the smallest number, so we are not updating that variable. Next we compare the start element and the end element. So in this case both are same. Execute the else part, and again we compare the last element with the smallest, and we hit this else part. So the end pointer will be updated with mid minus 1. In this case it changed from 4 to 3. Okay, then when we in the next iteration this condition is false, so we break out of the loop because 3 is less than 4. Okay, then finally we return the smallest variable's value as the output. In this case it is 1. That is an expected output. Next I'm going to do the time and space complexity analysis for this solution. The time complexity of this procedure is order of log n. Okay, so for example this input array has 5 elements. So in this case this for loop performs 3 iterations, which is equal to log 5 base 2 plus 1. Okay, if there are n elements in the input array, then we ended up this for loop performs log n plus 1 iterations. Okay, so we remove the constant factor out. That's why the time complexity is order of log n. Okay, space complexity is order of 1 because we are not allocating any additional space in terms of the input size. We use only few variables, so that's why the space complexity is order of 1. Thanks for watching this video. Have a great day.